Hey Brainy Buffs, it's Miss Crain, and what Miss Dooley is trying to show you in this picture is what your notes should look like when we're all done today. The only exception to that is this page 45. That was where we put it last year. This year it's probably going to be on a different page. So please put the notes on the page that your teacher told you to put them on. Now before we get started, I just feel like, Miss Dooley, she's all about the school spirit. She's all about Extreme Orange. And I just felt like she needed a little mustache right here. So I think I'm going to help her out with her Extreme Orange and give her a little more orange to brighten it up. And like any good hairstylist, I'm going to make her eyebrows match. Oh, that looks so much better. Oh, that's awesome. So now remember that I did that because we're going to ask you about it tomorrow. Okay, so any discussion of the atom has to start with defining what an atom is. So an atom is defined as the smallest particle of an element that has the properties of that element. Now that is a really important idea, guys, is this concept that we define it as the smallest particle of an element that has the properties of that element. Because as we talked about with the dead guys, an atom, we've discovered, can in fact be broken down into smaller particles. It used to be that we thought that an atom was the smallest particle of matter, but we discovered later that it's not. We can break it down into smaller pieces. But the key here is that once we break it down into those smaller pieces, it no longer has the properties of that element. The atom is the smallest particle that can do that. So that's kind of an important idea to have in mind. Now, we said that it can be broken down into several different pieces. So what are those pieces that we can break an atom into? Well, the first one you need to know is called the proton. Proton sounds like positive, right? Pros, good things, protons. Okay, so we often abbreviate proton with a P and a little plus symbol on the top right. Okay, because protons are positively charged particles. A proton has a mass of 1 AMU. An AMU stands for atomic mass unit. And so when we're talking about the mass of an atom, we talk about it in terms of AMUs. So one proton is going to supply an atom 1 AMU of mass. Okay? The next particle that we need to talk about is called the neutron. Neutron sounds like neutral, right? And that's exactly what it is. It's got a neutral charge. In other words, it has no charge. Charge of 0. Okay? But a neutron is also going to supply the atom with 1 AMU of mass. So together, these two particles make up what is called the nucleus of the atom. Now, this is not to be confused with the nucleus of a cell. Last year in biology, you guys talked about cells, you talked about parts of the cells, and you learned that the nucleus was the brain of the cell. And that's absolutely true. But we also use the word nucleus to describe the central part of the atom. And they're very, very different things. An atom, remember, the smallest particle of an element. Okay? Whereas the nucleus is made up of lots and lots of molecules that are made up of lots and lots of different atoms. So, really important to kind of keep that difference in mind. Okay? So there is one third particle that is not contained in the nucleus, and that is called the electron. Okay? This one is a little less obvious what its charge would be, but we have positive, we have neutral, so this one's going to be negative. The electron has a negative charge. Now, we talked about the mass of a proton and the mass of a neutron being what makes up the mass of the nucleus. The electron has such a small mass, it's actually 0.0005 AMU, which is really, really small compared to that of the proton and the neutron. So when we talk about the mass of the atom, we're really only talking about the mass of the nucleus. Okay, the mass of the protons plus the neutrons. the mass of the electron is so small and so insignificant that we really don't consider it in terms of the mass of the atom. Also, the electron is constantly moving. So the nucleus is kind of central, and the electron is moving about it in what's called the electron cloud. Okay, so 3 parts to an atom, 3 main parts. Now you may have heard of some of the other particles that we can break that down into, like quarks and things like that. But at this level, we really just want to focus on these 3 main parts of the atom. So let's talk about, let's draw a diagram of an atom and look at what it would look like. Okay, so in the nucleus we have the protons. Let's pick a simple atom. Let's do helium. So in the nucleus of a helium atom, we would have 2 protons. How do I know that? Well, helium has a atomic number of 2, so that tells me it has 2 protons. It also typically, not always, but typically has 2 neutrons. So there's the nucleus of the atom. So it's got 4 subatomic particles in it. And so this is going to have a mass of 4 AMU. Okay? So then around the outside of our nucleus, we have what's called the electron cloud. And this is the area of the atom where the electrons are most likely to be found. And helium, it has 2 protons, so to balance that out, we're going to have 2 electrons. So this out here is the electron cloud. So an atom of helium is going to have 2 protons, 2 neutrons, and 2 electrons. So that's going to be our atom of helium. Okay, so when we're looking at the periodic table, we have, remember we discussed groups, and those are the ones that go up and down. Okay, so we have group 1, group 2, group 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 total groups. Okay? Now, the group number is going to tell you how many valence electrons an atom has. Okay? What is a valence electron? Okay, how is that different from a regular electron? A valence electron is the outermost shell's electrons. So the electron's the furthest away from the nucleus. Okay? Atoms are built with different energy levels. It's kind of like going up the stairs in a building. Each stair requires more and more and more energy. Same thing with the different levels of an atom's electron cloud. The closer it is to the nucleus, the lower the energy. The further away from the nucleus, the higher the energy. So what's cool about this is that it's pretty simple to tell. Groups 1 and 2 have 1 and 2 valence electrons respectively. And then groups 13 through 14, it's the second number of the group numbers. So group 13 has 3, group 14 has 4, group 15 has 5, 16 has 6, 17 has 7, 18 has 8. So that's what the groups can tell us. And then we also have what are called periods. Okay? Periods, remember, are the ones that go side to side. And there are 1, 2, 3, 4, 5, 6, 7 periods. And the period tells you the energy level of the atom in that row. So for example, carbon is in group 14, so it's going to have 4 valence electrons. And it also is in period 2. So its valence electrons are in the second energy level. Carbon has a total of 2 energy levels. Okay, so what do these energy levels tell us? It tells us how many electrons we can put into it. So at the first level, there are only 2 elements, there are only 2 electrons. At the second level, we have 8 elements and 8 possible electrons. At the third level, there are 18 elements and therefore 18 possible electrons, and so on and so forth. So that's kind of how we can look at the periodic table and get some information about each of the individual atoms. So now let's look at what an individual square of the periodic table can tell us about that specific element. So the first thing I want to talk to you about is this number here. There's always going to be a whole number, a 1, 2, a 3, a 4, a 5, 6, etc. Okay, always a whole number for every element. This is referred to as the atomic number, often represented by Z. Okay, this tells us the number of protons, which therefore gives us the identity of the element. So, regardless of how many neutrons or electrons an atom has, if it has an atomic number of 6, if it has 6 protons, it's always going to be carbon. Okay? I could have 56 neutrons and 6 protons, it would still be carbon. Of course, that would be too unstable to exist, but that's the point, is that it always is going to be what identifies the element, is how many protons it has. Now, in a neutral atom, in other words, an atom with no charge, if it's going to have no charge, the number of electrons has to be equal to the number of protons. But that's only if the atom is neutral. And we're going to talk later about ions where we change the number of electrons and it's no longer neutral. But when we have a neutral atom, the protons and electrons are both equal to the atomic number. So that's that number. And then we have another number up here that's called the average atomic mass. Okay? And this is not to be confused with mass number. The mass number is something totally different. So what is the mass number? The mass number is the total number of protons plus the total number of neutrons. In other words, it's going to tell us the total mass of the nucleus. Because remember, we don't really look at the mass of the electrons. We're only looking at the mass of the protons and the neutrons to determine the mass of an atom. So that's going to be our mass number. So for example, let's say I had an atomic number of 82. Well, if you look on your periodic table, element number 82 is always going to be lead, regardless of how many neutrons and electrons it has. If it has 82 protons, it's going to be lead. So that means that it has 82 protons. If it has a mass number of 207, that means that we have 82 protons plus however many neutrons. So to figure that out, we take 207 minus 82, and the number of neutrons would be 125. Okay, so that is all that you guys need to do in your notes for tomorrow. But you know, before I go, I just feel like I have to tell you just how much I really, really could go for a dill pickle today. That sounds really good. Have a great day. We'll see you guys tomorrow.